So to make the parent functions for y equals sine theta and y equals cosine theta, you just need to look at the multiples of 90 degrees or pi halves radians on the unit circle and realize that the rule for cosine theta is to look at the x value, and for sine theta, it is to look at the y value. So I will now do that and generate the sine theta function very quickly. So if you notice here, as we're on 0 degrees, the y value is 0. And then when I move to 90 degrees, or pi halves radians, it is going to be 1. And then when I move to 180 degrees, or pi radians, the y value there is 0 again. And when I move to 270 degrees, or 3 pi halves radians, it is a value of -1 for the y value. And then when I move back to 360 degrees, I get the equivalent value as when I was at 0 because they are coterminal, which is 0. Again, that's focusing on the y value to make y equals sine theta. So that is one cycle of the sine function, and they are the parent points. Okay, similarly now, if I wanted to look at the cosine values, I would just look at the x values there. So I will go around again, make a different graph. You'll see some similarities between the graphs here. Okay, so when I start at 0 degrees, or 0 radians, you see that I get an x value of 1. And then when I move to 90 degrees, or pi halves radians, I get an x value of 0. And then when I move to 180 degrees, or pi radians, I get an x value of -1. And then when I get to 270 degrees, or 3 pi halves radians, I get an x value of 0. And then when I move to 360 degrees, or 2 pi radians, which is again coterminal to 0 degrees and 0 radians, I get an x value of 1. So this would make one cycle of the cosine graph, and these two parent graphs should get committed to memory. If you want a better explanation, watch the longer video that preceded this one, and that should be able to do you well if you've already seen that video. Just plop these parent points down very quickly.